protecting smart cities and industrial IoT, how we can securely scale with edge and AI. I've got a distinguished panel. I've got a member joining us remotely on Zoom. So thank you, Dr. Tom, for joining us while you are not physically present. I've also got a brain trust here to my left, and I'll let them introduce themselves here briefly. I'll start with you, Dave. Go ahead.
Yes, welcome again, everybody. Hope you enjoyed your lunch. My name is Dave Eifert. I'm the Senior Business Development Manager for IIoT here at Phoenix Contact. I actually work in Cleveland, Ohio, where I live, but we cover the country. And yeah, it'll be our pleasure to talk to you about how we can keep all this kind of stuff safe throughout this session. Aaron?
Yep, I'm Aaron Olsbrook, CTO and co-founder of a software company called Clearblade. We do IoT, believe it or not, here at the IoT community. But it's a pleasure to be here. I've had the pleasure of working with all of you guys, so it's going to be fun to have a conversation. If I can remember all our terms, edge, IoT, AI, and smart cities, we're going to do a lot here. So thanks for having me.
Right on. Paul.
So hello, everyone. Paul Vedetti. I'm an advisory industry consultant with SAS, and I'm in the IoT division. So I guess I'm in the right place. And again, I'll contribute some of the thoughts around, especially relative to analytics and AI relative to this topic.
Wonderful. And obviously, last but certainly not least, Dr. Tom.
Definitely least, and I appreciate being part of this, even though I can't be with you at this time. The current role I have is rather intense. And I have had a history of the edge, the cloud, as well as the data center at IBM, National Instruments, Hewlett-Packard. But today I work for a company called IIoT. I'm the Chief Product Officer and CTO, and we fight cybercrime and cyber warfare every day, head to head. So I'm happy to address this particular topic and the security dimension, as well as the AI dimension today.
And we thank you for that, because I'm going to start with the first question right over to you, Dr. Tom. I'm going to ask you, why are we here today? Why are we on this panel? Why are devices and things that are connected, why do we need to protect them? Talk about, as devices scale and that population grows, why it's so important to protect that attack surface.
You bet, and you use the term attack surface. The predominant and dominant one today is normally a PC or a laptop. However, an emerging attack surface, and I'll be talking about this at a cybersecurity conference in October, is what we call the edge, or the devices at the edge. As you point out, there's about well over 30 billion will be in the year 2025 of these devices, and just statistically, about 30% of the endpoints attached to an enterprise data center are our world of the IoT, the things, the T in the IO things, or smart devices. Let me say, if the thing is smart, it's a security vulnerability. And here's what I mean by that. And I'll answer very briefly here. I like to put them in the category 3 Ps. Well, one of them is the preponderance, like I just talked to you, many, many billions. There's so many of them, so you have a statistics game of being able to penetrate one or more. The second is proficiency. And that is, as something is smart, the computer stack that is well known, even if it's on a single chip, of a bare hardware, if you will, then operating system, virtual machines, IO, NICs, network interface connections, are simply lifted from our computers and put into things and devices to make my coffee cup smart, to make my camera smart, to make my car smart, to make everything smart. So if you're as we call a threat actor or a criminal seeking to penetrate, so well, I already learned how to do that on a PC. Thank you, device world, for building in that same stack. But the interesting thing about it is when it was lifted, if you will, and imputed onto smart devices, they left the security behind. So a lot of security has happened with laptops, with even cell phones, of course, PCs, but these smart devices are lacking it. And that's the third P, is the peculiarity of it. It's unfamiliar to the device manufacturer, the security. Not all, of course. I don't mean to be negative about it, but it's just not top of mind like it is now with laptops, desktops, and those other attack surfaces. And So let me just stop there in the interest of time, but I think the three Ps are the reason why the attack surface of the edge and the IoT devices is growing and growing rapidly.
Those are all great points, and I know that Dr. Tom talked about what got left out. Dave, what are some of the misconceptions? What are some things that are misconstrued about securing edge devices in IoT?
Well, I think this is a really good segue from Dr. Tom, and he mentioned that the peculiarity of the things, the devices, the smart sensors, the edge gateways, and that they're very much physically and software stack similar to the computers that are now being protected. The funny inversion is about 10 or 15 years ago, that worked in the device's favors. People thought of security by obscurity because they thought, oh, these people don't even know what PLCs are or other types of intelligent devices out on the factory floor. Therefore, they won't hack them. Well, then came along Stuxnet, and since then, that whole genie's out of the bottle. So it's kind of ironic now that it's just the opposite of security by obscurity. We've got to be very intelligent about how we deploy security on these devices. One example of that is one of the things that we use as an edge gateway is called our PLC Next platform, and it's designed and manufactured in Germany. And we've intentionally designed it based on IE 62443 security standards. It's a standard which has kind of evolved over time and now incorporates device manufacturers, system integrators, asset owners, and then a general category. So things like designing your product from the ground up around those standards, putting features into your product that such as a TPM 2.0 chip and other things like this to enhance security. So it's got to be incumbent upon the device manufacturers to be very intentional about building that security in its own right, but also as part of an ecosystem that it can be protected with different types of existing technologies that are out there.
Yeah, I'll chime in. Am I allowed to? It's a chat.
Absolutely.
Yes,
All right,
please.
So I look at it. It is interesting, right? Security by obscurity has been so important, especially in the industrial space, right? But the problem is we've all been working to unlock these things, right? That the brownfield is the holy grail of where data is. So you've had at least I think I'm a positive actor, desperately trying to reverse engineer protocols, get data out, and pretty successful, right? Within a week, suddenly things that no one ever had seen except in these private systems is now flowing other places. So it's almost like we have to appreciate that we have some obscurity and enjoy that we have it a while longer. But in the end, we have to move to standards and these best practices for it to really come together all the way down at that device level.
And while add on, I think the other thing that I'll add to is you mentioned Stuxnet. I think the insider threat. A lot of times I think one of the misconceptions is that the foreign actor, the threat is a foreign actor, a nation state that's going to try to crack into our system. I think that it's really important to think about the insider threat risk. So that makes you have to think about like what are you doing from a zero trust perspective, a different kind of thinking, and especially when you're talking about smart cities where the impacts could be very significant if somebody on the inside was to do something to traffic management systems or things that protect cities and infrastructure and safety in general. So I think that's another area that needs attention when we think about this.
What are some of the key points, some of the key elements in that life cycle, Paul? What would you say are some of the key things to consider and look at inside of that entire life cycle from day zero to the end of a deployment?
Yeah, let me take that from like an analytics perspective. I think there's like moments of truth, and I'll give you kind of 4 scenarios that I think you have to think about when you think about security. One of them is, operating at the edge. Let's assume that we built the model and it's running. It's just running, on the edge. That's one scenario. The second scenario is when you start piping data from an edge to a cloud. So now you have the scenario where you've got data movement going from edge to cloud. The next scenario would be obviously moving models and maybe firmware update from cloud back to edge. So it's the other communication link down. And one last one I'd add to make sure that you also think about is the, remote support. So there might be an issue that tech support, a person that normally has no, privileges otherwise, is maybe having to access it. And I think each of those 4 scenarios paints different needs and thoughts relative to security design strategy. So, the secure boot of software, knowing what's running. And from an AI perspective, when we're running on the edge, we want to make sure people aren't potentially able to decipher the logic, especially if it's a critical AI workload happening at the edge. If they could decipher the decision logic, or if it's exposed, that might be the key. They need to know what to do to cause harm. So obviously we always talk about data encryption, but we do have capabilities on actually the model encryption. So that's something that is always on the table as an option if that's warranted for a given use case. And then I think the other methods of moving data from edge to cloud, there's certainly the data encryption in transit, the long-lived tokens that you're kind of managing, and then back the other direction. I think making sure that the updates come from trusted environments. And then lastly, I'd say on the remote side, just as an example, I've seen scenarios with critical infrastructure where you have VPN tunnels and you have almost data diodes. The data can only, for that support user, the data can only go one direction. So again, depending upon the criticality of it, you need to have kind of thoughts of those four scenarios.
That's a terrific breakdown, and I think that what I'd like to key on next, Aaron, I mean, it's been talked about today, AI. It's been talked about in the news media. It's at the forefront of a lot of different companies' strategies. Let's just get it out of the way. Is AI posing a risk to security?
So unfortunately, probably yes, right? I mean, we see everybody's getting better at everything, right? White collar workers, blue collar, everybody's using AI to do their jobs better. And AI is a great tool if you're a hacker to get better at it. We've been looking at how can we use it to more quickly crack these old protocols? How can we more quickly connect up a device? If suddenly we can try 1,000 different permutations and guess at the right ones faster for different ways to get to that PC, right? That's where it lives mostly today, to Dr. Tom's point. You're just accelerating the abilities for people to do this, right? And so good actors will do some very positive things, but the bad actors are going to use it as a chance to figure out what was very obscure stuff very, very quickly. That's why we don't have a lot of time, right? And I'm spinning on your zero trust, right? It took me a long time to understand that statement because I was like, everything has to have trust, right? And so really it's just going back to saying you trust nothing and reestablishing that trust each step along the way. So you no longer assume that your integration's a good guy. You no longer assume that the user's a good guy. You no longer assume anything in the behaviors that are going on. And that's where we have to get to. We have to get to a very high trust environment where everything, every part of it has been reevaluated. They are who they say they are, all of that along the way. And that's how you're going to ultimately protect against some of these AI tools, which are going to find those trust exposures.
I'll just add one more thing. I think with the zero trust, I think the other concept I think is important too is physical access control, worrying about the physical tampering. So having access to specific rooms, logging, so some of the bad actors, come in on a weekend, or odd hours. So it's also thinking about, those concepts too, the physical intrusion kind of scenarios as well.
I love you say that, right? Because if you look at OT, and we've always been trying to do this stuff, right? Trying to figure out trust. OT is incredibly good at that, right? They've got gates on everything and padlocks and 4 or 5 through, but IT on the other hand has just let you in the building, right? So both sides are good at pieces of it, and then trying to figure out how both to do it well.
So
Can I make a point on AI?
Please.
If I may make a point on AI, I think in encouraging those listeners that the best way to stop a bad person with AI is a good person with AI. And I want to encourage people to use AI for good because we have to, because as was being said by Aaron and others, the bad actors are using it. It's a fact. And if we're worried about, if you're worried about AI, you ain't seen nothing yet with quantum, computing. And that's, of course, on the horizon, as you know, but we need to get the good people involved in AI and quantum computing because we know it's coming, from the bad side. So I just like to encourage, especially if they're young people, thinking about career opportunities. A lot can be done to do that. My team and I are working on that very problem right now, and it's really fascinating to see. But always remember that it's the best way to stop a bad person with AI is a good person with AI.
Well put. And I'll stick with you, Dr. Tom. So the critical infrastructure that makes up a lot of smart cities and a lot of smart city components. They include, police communication, first responder communication, all the way down to utilities and grid systems. Why are they such vulnerable and focused targets for these bad actors?
Well, they are indeed. In fact, I got a call from the mayor of a town who was hit by a threat actor. And as we talked and we studied a little bit what happened in what we would call incident response, responding to that, incident. What was profound about that was that the police communication systems was taken down, and also the utility, particularly utility billing system. So those two, which you mentioned, are particularly vulnerable targets, and here's why. We know from American history as well as other history that if you withhold police protection, chaos will ensue, right? Crime will increase more and more. That's empirically proven, even in recent history, a few years ago. So therefore, to target and take it down, in this case, involuntarily through the communication system, will cause chaos. Number two, taking away lights and electricity also promotes looting and chaos as well. So you notice the theme here of chaos, crime, and disorder would be what we call a nation state or enemy of the United States attack. And that's why they're vulnerable, because if you can take the utilities out and you take the police out, you can get more immediate chaos. If you take the food system out, obviously that would create chaos for survival, but that would take a little longer, because most of us have in our pantry in America food, and then, it would take a while. And to completely eliminate all food supply is a little bit tougher, but to completely cripple police systems in cities and towns, and to cripple the utilities, water supply, electricity, is not as hard. And that's why. Oh, but why, you might say, why, I'm sorry, real quickly, why is chaos, a weapon as opposed to a conventional military attack? Well, again, if we look back at history, creating chaos in a society forces control. And if you force control, you can then take over, right, from from a government perspective. So that is what we think is the strategy of our enemies.
So Dave, Dr. Tom has painted a pretty grim picture for us here. So
Tough act to follow right there.
tell me, and for everyone in the audience and everyone online, so what can we do? Let's talk about actual tangible things that we can do for security in smart cities and industrial IoT.
Yeah, well, gosh, it's a huge question. I think adopting standards such as IEC 62443 and other security standards that are well recognized, well thought out, pretty holistic in terms of what they cover, who they cover, recognizing that you can't just build it into a product with a magical chip or one firewall or anything like that. That's got to be part of the puzzle. But then you've got to also make sure you have policies and procedures, things like lockout. So it's people, it's maybe fencing, maybe surveillance. It's a holistic approach at every step of the way. And I think standards like 62443 do a good job of kind of stepping back and look at all the different facets that you've got to consider, and giving those roles and responsibilities to manufacturers of the devices, to system integrators who are putting it in, to the asset owner who's going to maintain and operate these systems. And it's got to be all of us in concert together working towards these things. And it's to the point earlier about zero trust. I never liked that term because it's just counterintuitive to the human condition, right? But it's almost like you do have to take that step back and say, I cannot make any assumptions anywhere along this chain. We've got to assume the worst, unfortunately, and try to guard against it, and ever remain vigilant. And oh, by the way, at the same time, try to be as open and communicative as possible so you can enable these things like IoT and get the big data where it needs to be and process it and do AI on it and ML on it. So it's a really daunting challenge, but it's one that if we don't address it, it's going to be too late.
So there's a lot we can do right now. And I think the other thing that comes to mind, and you can blame Dr. Tom for putting this here in my brain, but like new stuff is coming, right? And we don't know what it is, although we know quantum's coming, right? But already, like a couple weeks ago, NIST released their quantum encryption algorithms, right? And now suddenly I have to go Google what lattice encryption means and then become an expert on it by the next time I have a conference, and right, this whole journey. So the idea that even if we did every single possible thing in a way that was cost efficient today, we're going to be rolling new root CA encryption algorithms in 5 years or 2 years, and we better know how to update constantly, right? And that's a big challenge for industrial infrastructure. It's a big challenge for cities because those folks have often just been able to air gap and not have to change. And it's a complete, warp of what we've been doing and how we've been maintaining these systems. So, yes, a ton to do today, great standards, but it ain't done. It's not done.
No.
I think what I'd add too is, from an AI perspective, when we say good AI can help, I think the things that are possible are things like data integrity checks, being wary of data spoofing. If somebody's doing something, it's like which data is sensitive to driving potentially an outcome that is most risky. So not all data is equal in the cybersecurity space. So understanding where we're vulnerable if something were to be hacked, it may be prioritizing maybe techniques, but maybe even AI to monitor that, because again, sometimes it's hard because there could be legitimate reasons that data's awry, but there might be behaviors of the data that just don't make sense that could trigger some actions. And I think that's important with we've always said that with AI and cyber related things, that you want to detect it's happening. You don't want them lurking in there and hanging out a long period of time, because the longer they're hanging out, the more they're able to figure things out and potentially get to that next level, because they're in on one level, but they're trying to get to additional levels to cause more harm. So it might start innocent and first level, but again, it's the progression of it. So detection is important. So and this comes back to a lot of other things with AI, the experts can help. The experts know what's normal behaviors within their systems. So I think the idea of, providing kind of that surveillance that could be informed by experts. I've seen that. I know that there's been R&D work and projects done around monitoring critical infrastructure assets with that idea of understanding what's within the boundaries of realism. That's certainly proven R&D that's happening and being funded by the government that could be promising.
Right. So, Aaron, when we're looking at and we're talking about security, is there really a difference between securing a consumer product or a corporate laptop versus something in the smart cities and industrial IoT realm?
Well, I think they're coming from different places, right? I think in the end, to Dr. Tom's point, we're probably going to build on the same infrastructure and pieces when it's all said and done. We're going to use the practices like Things Contact is putting together in that PLC Next package, but they're coming from very different spots, right? Essentially, if you made a smart home device, you really didn't trust the user you were selling it to anyway, right? So it was kind of zero trust. You figured they'd push all the buttons wrong, they'd install it the wrong way, and they'd open 75 tickets instead of one, right? So that smart connected world has mostly, and it's lived over the public internet, so it's not like you trusted the network along the way. So I feel like a lot of those devices that we're most familiar with probably have helped us define the zero trust attitude that we're realizing we need to take on our tractors, on our water pumps, those kinds of things. But they're coming from different spots. OT is great at securing physically. Meanwhile, our smart home devices are screwed in the ceiling and can be grabbed anywhere along the way, right? So they're coming from different sides, but ultimately they are going to have to run together, right? We're going to have to learn from both. We're going to have to use the best practices in both. We're going to have to take phishing out of homes along with phishing out of workers, those kinds of behaviors that are making us vulnerable today.
Great call out. Yeah, what I'd also like to talk about with the rest of the team here, and Dave, maybe you can kick us off. Are there any real panic buttons? Are there any issues where we need to sound the alarm and get word out? Or from your experience, is it a more methodical process where you're building out security and strategy, and that's from day one where you're able to do that in kind of a calculated and a predictable way?
Yeah, it depends on how urgent, things will be imposed upon us and make us hit the panic button perhaps, but absent that, I think a methodical approach is the one to take. And there's certainly a lot of things. I used to work extensively in the water sector, and it's very, as Dr. Tom said, it's a critical infrastructure, very vulnerable in many points to really affecting human health. and sowing discord and chaos throughout society. So you would have thought if there had been government regulations that they might have been imposed upon a sector like that, but there really haven't been. So it's really voluntary to this point. Having said that, there are a number of different organizations that are promoting a very methodical, holistic approach towards security. And it's just incumbent upon everybody to actually adopt those things and see them through and change behavior of the workers there that have been doing things a certain way for years and years and are frankly, not that motivated. When you've never seen a real big problem, you're not that motivated to fix it. Then something like Oldsmar, Florida, you might remember about 3 or 4 years ago, was all of a sudden there's some anomalies in how the systems were working, and dangerous levels of chemicals were getting into the system that could have been deadly to people that was stopped in its tracks, but that sent up a lot of alarm bells. So I think if you can use somebody else's misfortune as the impetus to get you moving, do so. We all have to do so because it's very real. It could just be a matter of time before it happens to us.
I'll pick up. I agree. It's a methodical process. There's one area that I'm always concerned about, and maybe it's thinking in terms of an incident response. If you're not ready and not able to fix things quickly, that you should take very, very urgently, right? If you don't have a way to recover, you can go back and improve authentication. You can go back and improve, but you've got to be able to update that model that might have been. And so to me, that's the one thing when somebody says, well, we'll drive all the trucks back into the factory, or we'll move all the boats back into port, or whatever they're saying. And I'm thinking, you guys don't have a way to respond, and that's scary.
Yeah.
So to me, we're always going to be getting better, but if you don't know how to get better quickly, then you are quite vulnerable.
Well, may I add to that, please? Very excellent point, Aaron. As you mentioned, incident response. Yes, let's not let it happen. But if it did, what are you going to do about it? I know a large company that was ransomware, as we call it, and the whole system was taken down. Multi-billion-dollar company systems are taken down, and the threat actor said, if you pay me a ransom, I'll give you the encryption key or the decryption key. And they said, no, we have a backup. So they went to use the backup, and guess what? It didn't work because it wasn't tested. So keep going deeper and deeper, right? Testing as well. Not only do I have a backup, but since it wasn't tested, now it failed. And then, long story short, had to go back to the threat actor and facilitate. Now, with that all said, it's extremely important to also think about, if you are hit, how many days will you be with business discontinuity? Because that's a cost every day. In fact, the largest cost to a cyber breach is not the ransom, but it is the business discontinuity, or the business disruption, as it's called. And if you think it'll take 6 days to recover, then you should have that amount of insurance. If you think it'll take 2 days, et cetera. So I'm just throwing out some practical things for the audience to think about with respect to their government, their smart city. They're all run by IT systems, right? Everything's about IT. That's the attack surface of an IT breach, as well. Good point.
Yeah, I guess just one thing I'd add to the conversation is as part of that plan, fallback versions. So I mean, if the model is rolled out, and unfortunately things are happening at scale now. So if you put it out at scale and you've got a problem now at scale, the plan from a modeling perspective could be just, do you have kind of that blue-green deployment strategy where you can fall back to a trusted one that didn't have this problem in case something happened take place. So something like that could be at least considered for cyber-related incidents. It'd have to be, obviously, as Dr. Tom said, I think you have to test this. And I think people do test this. I think, I've seen organizations, they actually create that day, that problem day, and actually handle it like it's real. Because if you don't test it in some kind of real scenario, you won't know, how it's going to work with the real scenario happened.
Yeah, I'd just like to jump on one last topic, or just follow on this thread one more time. And Dr. Tom brought up business discontinuity. It doesn't really matter if it's a threat actor, or an accidental inside job, or an intentional inside job, or an act of God, like a weather event, a hurricane. So what I'm saying there is there may be additional reasons besides simply cybersecurity to seek that resilience and to build that resilience into place. So if you're hit with a hurricane, can I get back in 2 days instead of 10 days? Same thing with cybersecurity. And some of these measures that you would take to protect against one could protect against the other. So the real objective is to stay in business through the whole thing. If you can't, how do we get back as quickly as possible? And there could be additional justifications beyond just a cyber threat. It could be, like I said, weather related or other types of things that could take you down that you also have guard against. So I think the mindset needs to be resilience.
Very well said. Aaron, in creating a security process, is there any issue with scale? So does creating a security process become a larger mountain when you're talking about securing millions of devices and millions of endpoints versus one physical infrastructure item and a small handful of devices? What does that mean for when we're talking about scale?
Well, scale's always harder, and scale, like security, often is thought about later. So scale is unique. I'll take it from a couple angles to start with. If you think about if you're trying to do all this encrypting 4 or 5 connections, your computer doesn't notice it. Trying to do the encryption and unpacking and the TLS and the termination and the authentication, that's often some of the biggest hits you'll see on your computers, quite frankly, as you're trying to run at scale. So it's certainly not a cost you go in when you're thinking about, I got this telemetry data, but that hits you at scale, and you see that in quantifiable ways. I think the bigger thing is what you were talking about, Paul, is now at scale, we can push and we can create messes so much faster, and to understand what is where at what moment in time. And in a world with edge where things go online and offline, and we heard about reasons why we want edge because we can remotely process, but now we don't know what it's processing and when because it might, that is a whole nother challenge, right? And we've got a lot of smart engineers out there who today can look at 25 pumps and very quickly go patch, all 25 with shell sessions behind the scenes and all kinds of stuff. It's totally unviable at 1,000, at 1,000,000. Oh my gosh, right? It's a non-starter. So you have to completely change your mindset of what is the action I want to take? How do I know I took that action effectively? How can I trust that that action was moved the right bits at the right spots? And how do I get back the other side of that? So to me, that's where scale scares us, right? And cities have it. The nice thing about cities is they kind of tend to be isolated, but certainly large cities have large scale associated with them. But the scale completely changes how you react to it, how you recover from it, and then how you do that deployment, which is why to me that how am I going to rapidly patch everything I've got? And in a world where I truly believe we're going to have 100x more connected things 10 years from now, no pattern that involves hours is viable today, right? The patterns need to be just minutes for how this rolls back out that you need to be setting today. So to me, I think the scale gives you probably the accurate way of how you need to solve this. So if you're designing these plans and you've got 100, you need to write 10,000, right? We've got to do 10,000 of these PLC next right now. What does that look like?
So it's going to be a question for every panelist. I'll start with you, Dr. Tom. What's next? What's next? What should we be worried about? What should we be excited about? Securing these types of devices in smart cities, in industrial IoT.
Well, to be excited about it in Pennsylvania, the state fair is coming up and they have fried Snickers bars. And so I thought I'd throw that out to counter some of the negative here. So if you're around, please indulge. Hey, real quick, I have taken the Hippo Cyber Oath. There's really not that, but the point is, I have to say a few things really quickly. Number one, put limits on your auto pay withdrawal if you're paying. And by the way, real quickly, it all comes down to the individual. Like we're talking about cities and these vague things like governments, right? But it's individuals that through which the threat actor, can work. So keep that in mind because if a threat actor gets in and increases the auto pay, it can drain your account. You may get the money back per se, but the point is now you can't pay your electricity bill, you have overdrawn, et cetera. See again, creating chaos. That's what the nation state wants. It's not so much that they took your money, That's a, organized crime, but the state and nation actor. Real quickly too, don't click on anything, ever. Okay. Okay, let's have a test. What is okay to click on?
Nothing.
Nothing, right? Now, I realize that's not completely practical, but that is a good rule of thumb. Don't click on anything ever, because that's how malware, gets loaded in the individual, and the whole enterprise or the smart city enterprise can be taken, down as well. And then stop signing up for every possible thing. Club of the week of this, club of the month that, et cetera, because you're continually putting your, information. And what the threat actors like to do is take a piece here from Facebook because you told everybody who your favorite teacher was, when you were young and you got all excited about your favorite rock band. And so don't be, putting things on that are socially interesting on social media, because the threat actor is behind that, right? Asking you, what was your favorite automobile when you were growing up? Because that sounds like a security question, doesn't it? He goes, well, so I'll stop there. There's a long list, but in the interest of time, I just thought I would pass on. Keep those rules. Don't sign up for things. Don't participate in social media surveys, and do not click on anything.
That is very good advice. Very good advice. Dave, what's next?
Man, I'm getting scared. I don't know. It's hit the bar. That's what's next for me. I guess what's next is just, I think the culture has got to be changed next. That's the number one thing to me. It's none of this really works unless there's a cultural awareness throughout every organization and families and everything else. We get stuff. We have a great IT department here, and they try to keep us educated, and sometimes try to trick us into doing things we shouldn't be doing, and see how good we are at not doing it. Every time I get that, and maybe you guys all do the same thing, I send it to everybody in my family as well, because it's just like, not that I'm trying to trick them, I'm just trying to keep everybody safe. And there's just so many innocuous seeming things out there that the payoff might be an endorphin rush for 2 seconds if you do it, okay? But really, if you take one half step back, you're like, what real value is this? So let me just not click on that thing. So I think it's a cultural mindset is the next thing we really need to embrace going into this next uber connected, virtual era that we're entering into.
I'll go next. I'm gonna steal your thunder. No, I'm kidding. I'll be a little optimistic. I feel like in a lot of ways we know how to protect the things. I think we know what the best practice is. Do we always do it? We don't always see it out there, that kind of thing. But I think, can we establish authentication? Can we do encryption that most humans can't unencrypt? Can we do authorizations? Yes. Can we build audit trails? Can we do updates? Can we establish trust amongst all these actors? I think we have patterns for that, and we know how to do it. So on one hand, I'm optimistic. I feel like the challenge we dreamed up of IoT 10 years ago, we know how to bring that into the businesses and the homes and infrastructure. I'm fascinated by what you said, so I'm going to leave a little meat on this bone, but I feel like there is something to wonder what is going to happen with these AI models, right? These AI models that I don't necessarily understand how they work. They got trained by data. I told them when they were right, and now they work. How do I even begin to know that I've put things out there that can't be abused and aren't opening up new ways, right? We saw that Gen AI was willing to sell me a car for $1, right? That kind of thing. So that's lightweight stuff, but there's more on there as we use this power. So to me, I think that's the emerging. I'm certainly worried about quantum. I'm certainly worried about things that are more years out, but AI models are hitting the field now, being pushed to the edge now. And so for me, I think that's the next spot of we don't quite understand that surface, to use another term you guys brought up.
I think one of the things that I see kind of coming next, I kind of see it from the consumer side. I've had so many data breaches in my family with this or that, and I get these alerts now that, your social security number and all my physical addresses I've ever lived on is on these email addresses. So it's like, I think I'm becoming a social influencer pretty quickly here by just this stuff. But the point is, I think the real-time credit monitoring that's emerging, must have 6 services now that's doing it. And I kind of look across and I'm going, by turning off your credit, your credit bureau stuff, you freeze your accounts, all 3. The simplicity that's coming with that now is promising. So I'm curious and the opinion that I think as cybersecurity becomes more realized with issues, that there'll be some of those kind of things in industry. relative to what we're doing that I think could be helpful too is there's a lot on model health, explainable AI, transparent AI, and having that be something that you'll see in a visual health model card that's interpretable. We're building that kind of environment and that kind of plumbing that would fit into applications. I'll talk briefly about that later in the day, but I don't see why cyber assurance couldn't be maybe hitched on to that concept if you knew what you're trying to convey, relative to application. So I think there's not that, I don't see that today at all. I think maybe what's next in the future would be some degree of cyber assurance.
Outstanding. I know we went exactly 1 minute over our allotted time. I want to thank the audience. I want to thank my esteemed panelists. Dr. Tom, thank you for joining remotely. Everyone, thank you very much.